Hi, this is Alex from devstories.eu. Mastering DeepChem, Episode 2 of 15. The biggest bottleneck in scientific machine learning is almost never the model architecture. It is trying to load massive files without crashing your RAM. Managing scientific datasets is how you get past that memory wall. When moving into DeepChem, a common instinct is to load everything into a pandas data frame. Data frames are excellent for two-dimensional tabular data, but scientific machine learning frequently requires higher dimensional arrays, multiple simultaneous prediction tasks, and per-task sample importance. DeepChem uses its own dataset abstraction because it natively binds features, multitask labels, and sample weights together in a strict format that models can consume efficiently. Every dataset object in DeepChem guarantees the presence of 4 parallel arrays. First, you have X, which holds your numerical features. Second, you have Y, holding your labels or the targets you are trying to predict. Third, you have W, the weights array. This is where it gets interesting. Scientific datasets are often sparse. You might have experimental data showing a molecule is effective against one target, but no data on whether it is toxic to the liver. Instead of dropping the molecule entirely or inventing a fake label, you set the weight for the missing task to 0. The model learns from the data you have and ignores the gaps. Finally, you have the IDs array, which stores a unique identifier for each sample, like a chemical SMILES string. Having a standardized format is useful, but the real power of the dataset abstraction is how it manages system memory. DeepChem provides 2 primary ways to store these 4 arrays. If your dataset is small enough to fit into your system memory, you use a NumpyDataset. Under the hood, this simply holds standard NumPy arrays in RAM. It provides extremely fast access and is ideal for prototyping or working with smaller collections of molecules. The limitation of NumpyDataset becomes obvious when dealing with real-world scientific data. Suppose you are working with a 100 gigabyte dataset of dense 3-dimensional crystal structures. Attempting to load that into standard in-memory arrays will instantly crash a typical machine. To solve this, DeepChem provides the DiskDataset. A DiskDataset does exactly what the name implies. It stores the X, Y, W, and ID arrays across multiple small files, or shards, directly on your hard drive. You specify a data directory, and DeepChem manages the storage. When you train a model, the DiskDataset only pulls the current batch of data into RAM. Once the model processes that batch, the memory is freed up for the next one. The transition between these 2 formats is entirely transparent to the rest of your code. You can write a training loop, test it locally using a small NumPy dataset, and then deploy that exact same code on a cluster pointing to a massive disk dataset. The model simply asks the dataset for the next batch, and the dataset handles whether that batch comes from RAM or is streamed from disk. Designing your data pipelines around this out-of-core streaming from day 1 guarantees your infrastructure will survive the jump from a few thousand experimental records to millions of generated structures. Thanks for listening. Happy coding, everyone.